channel Success Engineering Official. Today we are going to do the designing and drafting for VRF project. So we are going to do the VRF project. VRF project for G+5 building complete project. So let's before I start this video, I would like to request you guys, please do subscribe my channel and hit the bell icon as well in order to get the notification of my upcoming video. Please share and comment my video also. Please share, like and comment as well. So as you can see here, this is as you know, this VRV and VRF is variable refrigerant volume and variable refrigerant flow. This VRV is developed by Daikin, that's why its name is VRV, and VRF is developed by other brand like Toshiba, Mitsubishi, LG, Carrier. So we will start to the designing and drafting for complete project G+5 building. So as you can see in here, this is a G+5 building. This is ground floor plan, and this here is most of the places area is parking area, and only one lobby is there. And this is the first floor. So most of the rooms are office. So office building. This one is an office building, actually commercial building, G+5 building. So you can see here, this is the first floor, and typical is the second floor. Second floor is also typical, and third floor, fifth floor, fourth floor, and fifth floor. And this is showing the riser diagram. So as you know, before I start any project in HVAC, you need to do the load calculation first. So to save the time, because the video is going to be long, so I will calculate the load using thumb rule and manual calculation only. So as per for the actual project, you should calculate the load using E20 form or HAP. So I have already made the video how to calculate the load, cooling or heating load using HAP or E20 form. So I will give you the link in the description box, so you go and watch that. So as per actual practice, you have to use HAP or E20 form. But to save the time, I am using the thumb rule, and thumb rule is actually using for the small project. So as you can see here, this is the simple format for thumb rule load calculation. So this is a simply type serial number here, and this is the floor. So you have to calculate load for the ground floor first. So ground floor, you can see here, this is the lobby. So simply type here ground floor, space name is lobby, area. So how much is the area? So you can see 5.1 by 6 meter. So 5.1 by 6 meter. Area is 30 square meter. So 31 square meter. And this is the area factor. So factor for the commercial project 0.07 we consider. As you can see here, for the commercial 0.06 to 0.07, for industrial and hospital 0.08 to 0.09 we generally consider. So I'm consider now 0.07, and you can get here capacity in tonnage. See, area into factor is called capacity in ton, and this is dehumidified air or airflow. You can see here dehumidified air, dehumidified airflow, dehumidified airflow. Okay, and similarly you have to calculate for the ground floor and first floor. Now we are going to calculate for the first floor. So we'll start from office 1, office 2. Area is already given here 50, 41. simply enter here. This is the first floor, office 1, office 1, office 2, office 2 area is given 50, 41.8 is 50, here 41.8. So you are getting a tonnage and airflow. Okay, and copy this one. Next is office 3, office 4, office 3 67.6, office 4 67.6. Simply enter here. Office 3, office 4 67.6, 67.6. Same, copy this one, place it, paste it here. Office 4. Now next is office 5, 68.5, office 5, office 5, 68.5, office 6. Next is office 6, office 6 first floor, office 6 area is 72 square meter. So simply here 72 type, enter 72 square meter. Okay, so you can see here I get already the CFM and dehumidified air. Okay, simply copying, I am copying this one formula. So this is the first floor. Okay, what we'll do, simply we have to highlight this. This is for first floor. I'm going to highlight this. Okay, now for the second floor is the typical. So what we will do, this is the first floor, all the office I have covered, and next is second floor. The second floor you can see office 1, same typical, all are typical. So what we will do, we have to simply copy this. Third floor is also typical, and corridor is also. So corridor, I have forget corridor. Then fourth floor is same typical, only fifth floor is different. So up to fourth floor is same. Corridor is 19.6 to 1.6. Okay, the corridor 19.6 to 1.6, 19.6, 19.6 to 1.6, 31 square meter, into 31 square meter, first floor 8. Okay, okay, so what will do, simply highlight this. Okay, now next is what you will do, simply copy from here, and paste it down. Okay, and simply change the color. This is first floor, second floor. This is the second floor. Second floor is also typical, so simply highlight this just to identify. Okay, and then the second floor, after that third floor, you have to copy this one again. You copy and paste it here. Simply highlight this with other color. Remove this color and highlight with the green. Okay, so this is the third floor. Here, third floor, and then fourth floor. So what you will do for the fourth floor, you have to copy this. Simply copy this one. Floor name, area, space name, and area. Paste it here. Simply change the color. This is the fourth floor. Okay, so fourth floor, now you have to change the color also here. This is the fourth floor, and this one is the third floor. Okay, now the next is up to fourth floor is typical, and fourth floor is typical. Now next is fifth floor. So fifth floor, you can see there is only one office, 91 square meter office for the fifth floor. Here is fifth floor office, 91 square meter. Simply change the color, select this one and make this as a red. Okay, here is 9, next is 10, 11. Okay, so you can see here I have calculated the load already for the each floor. Now the next is you have to delete this. Let me delete this. Not required. Okay, you can see here I have calculated the load this for each floor. So the next is actually the step how to do the designing and drafting for the VRF project. The first step is the heat load calculation for individual space. Okay, the next is divide the building into the zone. So you have to divide, you have to decide the how many zone you are going to divide the building. For example, I am doing this project G+8, so I have to divide this in 5 zone, each floor 1 zone. Okay, so better you have to divide into zone, because one machine has to serve, one system has to serve in one zone because of maintenance. And for example, if the one machine is fail, so one zone is only fail, remaining zone is going to be served. Okay, so the third step is do the piping layout from outdoor unit to indoor unit as per the zone. Okay, and fourth step is do the equipment selection for outdoor unit and indoor unit, as and also the pipe sizing with the software or manual. And next is do the FHU design and then prepare the shop drawing. Okay, so our first step is over. So we are going to divide the building into zone. So we are divided into 5 zone. Now next is piping layout. So before do the piping layout, we have to place the unit. Okay, so what we will do, we simply place the unit in each space. So you can see we have calculated the load already. Now we have to decide the types of AC and we have to place it in each space. Okay, so let's start now. You can see here the lobby one. So lobby one is only one space, so we are not going to do the VRF design for this. We simply going to install the split AC. You have to decide or as per the space availability types of AC you supposed to decide types of AC. Okay, which type of indoor unit you are going to install in the space as per the space requirement, client requirement, interior requirement. Okay, so you can see here this we are not going to do the designing, not going to do the installation of VRF for this because of only one space. So we are going to install the split AC. So simply we have to install here split AC. So according to the load you have to check which type of AC you can install. So in the 2 ton, so we can install only split AC. Okay, so what you will do, I have made already here. I will show you. Let me open this file. So this is the split AC. Okay, so from here you have to copy this one, simply Control Shift C, copy and paste it here. Okay, Control V. Now simply rotate this. Move this one. Okay, I'm going to place it here on the wall. Okay, so this is the split AC, and you have to change this one. So this is already in the blocks, so you can change here. This is the size, and this you have to change to TR. To TR. Okay, so this is the 2-tier split AC. We'll do simply scale this one. This is showing too big. Now move this one, place it here. Okay, and then next is for the first floor. So first floor, office 1, office 2. We are going to install the cassette AC. So each space you have to place the cassette AC first. So you can simply copy this cassette AC. Control Shift C, copy, then simply paste it here. Control V. Okay, so each space you should decide as per the space and client requirement which types of indoor unit you need to decide. Okay, so I am going to use indoor unit as a cassette type indoor unit. For this office 1, 2, 3, 4, office 5 or office 6. For office 6, I am going to use split AC. So simply copy this one. But what is the done is, so this is the 5 done. So we are going to install two number split AC. Simply copy this one. So one is here, one is here. Move this, rotate. One is here. Okay, so to split AC, and what I will do, okay, I am going to place the text, another text here. Simply create one layer, type LA SEC VRF text. I'm going to use the yellow color, and line weight is 0.18. Okay, transparency is 0. Okay. Before I start this, you should lock this drawing, already locked. Okay, this is the our text. Now do the some dimension setting. So take new VRF text standard tender. Okay, set current, symbol and arrow, symbol and arrow is 100, text is 120, 125. We'll click OK, current, close. Modify this one, text color is by layer. Okay, set current, close. Now create text style. So text style, you should create one new style, VRF text. Okay, then here is Arial, text height is 125, factor 0.5, set current, apply, set current, close. Okay, so now you can type here text. AC 2 tier. Okay, copy this one. By layer. Okay, okay. You can see here I have placed this indoor unit in each space. For corridor, how much is the load? Let me check. Corridor is 2 ton. So for corridor, we are going to install the duct table or fine coil unit. So duct table, I'm going to select here. Let me open another. I will copy this one. Copy there. GG project chilled water project. Okay, complete VRF. Let me open this. I will copy the FCU from there. So just to save the time. Okay, so this is your FCU. This is your FCUs. So simply copy from here, paste it here. For the corridor, I am going to use this table. So this is the duct table AC. Okay. So as you can see here, I have placed all the AC unit in each space. Now I have to copy this the same in. Let me tag this. This is the duct table AC. Capacity is 2 TR. Ducted, ducted split 2 TR. Okay. Copy this one. Copy the text and place it here. Okay. So office 5, what will be the capacity? Office 6 is done. Office 5 is 5 ton. Cassette split. cassette split AC 5 tier. Okay, 5 tier. And the next is simply copy this one, paste it here, here, and here also. Okay, so for the office 1, you see here office 1 4 tier, then office 2 3 tier, then remaining is 5 tier, 4 3 and 5. This is the office 1 4 tier cassette split, office 2 3 tier, and the office 3 4 5 is 5 tier. You can see here we have placed the indoor unit for each space. Now the first floor, second floor, third floor and fourth floor are typical. So simply copy this one, simply all the indoor unit as well as its tag. You have to copy this one. Okay, and now simply copy from here, select any one point. I'm selecting this point. Okay, and simply paste it in each floor. Okay, so this floor done. Now third floor done, then fourth floor, the fourth floor. Okay, so all the floor this indoor unit I have placed. Now you can see here this is the fifth floor. So fifth floor, what will be the tonnage? So fifth floor, you can see here fifth floor 6 ton. So for the fifth floor, you should decide which types of AC you are going to use here according to the area and according to the space. And so better we are going to use 2 cassette AC indoor unit. So 6 ton, 3 ton each. Total load is 6 ton. So I'm going to use the cassette AC. So what I am doing, simply copy this. VRF is mostly VRF we are using cassette only. So I'm going to use here cassette. 2 cassette AC. Okay, 3 tier each. 3 tier. Okay. Okay, so we have already placed, you can see here we have already placed indoor units for each floor and according to the space. Now the next is we have to place the outdoor unit as well. So outdoor unit I already made it here. What I am doing, I am simply copying from here. Simply copy. Simply select this one, Control Shift C, the copy command, and simply place it here. Control V. This is the AC room, so I am going to place the outdoor unit here. So what we will do, simply rotate this, to rotate and move this one. Okay, so total capacity, you can see the total capacity for each floor is 28 ton. 28 ton is the total capacity. So I am actually we have already divided into zones. So what I am doing, there are 4. Actually, we are going to place the outdoor unit in ground floor here in the second floor. Second floor terrace is the AC room. So I am going to place the outdoor unit on the second floor AC room. So there are 4, 1, 2, 3 and 4. So 4 unit we are going to place it here. Okay, remove this. Okay, now copy this one. Simply copy. Okay, okay. So these are the 4 units which we are going to place, or what we will do. Please adjust this one a little bit. Okay, so these are the outdoor units. Now the next step is we have already placed the indoor unit as well as the outdoor unit. If I do the piping layout from outdoor to indoor, okay, so we will do the piping layout from indoor to outdoor. For this one we have to place one outdoor unit simply. So let us create one outdoor unit. Is easy. Let me make one layer. Is easy outdoor unit split. ODU split. Okay, and the color for this one is red. For example, consider this is as a outdoor unit. Okay, and this is the condenser fan. Okay, so this is your outdoor unit. Simply select this one, make convert into the block. Control Shift C, Control Shift V. Is converted into the block. This is the outdoor unit. Simply I am placing here for this unit. Okay, and for this one also I am copying this. Let me copy this and place it for the 5th floor. I am going to use. I am not going to use VRF for 5th floor. So treat this one each unit one outdoor. I'm going to use only a split system. Cassette type split AC. So these are your outdoor. These are your outdoor units. Okay, so next step is the piping layout. So we'll do the piping layout first. So this is only, let me create one layer for the piping. SEC slash refrigerant pipe. Okay, and the color for the pipe is magenta color. Okay, and thickness is line weight is 125. Okay, so piping is actually drawn with polyline command, so I'm using the polyline and the width I'm taking is 100. Okay, so simply draw this one, connect to outdoor unit. So let me create line type, because this is the line type here is showing already created. So select this one or get by layer. Okay, change this one to by layer. Okay, so this is the refrigerant piping connected indoor to outdoor unit. Okay, next is for this one. So first unit is for the first floor, this second unit is for second floor, third floor, fifth floor. So what you will do, simply connect this and this one, move little bit, move, select this one, select all outdoor unit and I'm going to move this side. Okay, so next is I am going to do the piping layout. So first of all, this is first unit is for the first floor. So what I am doing, I am taking PL polyline command, and from here I am going to select like this and go to this corridor. From the corridor, okay, so this is the corridor. So I am going to use the ref net here. So PL, again PL polyline, and I use the fillet command. Fillet radius 0. Select this one and select this one. I'm going to use the ref net here is to connect this. So ref net is here. You can see this is the ref net. What I'm doing, I'm copying this one. Control Shift C and simply paste it here. Control V. Okay, so this is the ref net for the branch connection. What I'm doing, simply move this one and paste it here. So this is the ref net join. Now from this ref net I am going to connect this. Okay, so you can see here this is going to be connected. Now the next is this going to be a state. Again one ref net I am going to use here. Again copy this one, paste it here. Okay, so from the here you have to simply draw ref net, go down, connect this indoor unit. Okay, next is PL. Use again PL polyline command and again use this one. Go to straight to here, or for this one you have to use one more ref net here. Okay, so copy this one, this ref net, copy paste it here. Okay, move this one little bit. I'm going to move this one little bit this side. Okay, again using polyline command, connecting here. Okay, and next is polyline command, simply move forward here. Now again use net, copy this one, going to copy here, rotate this, move, simply move and place it here. Okay, place it here. Okay, so you can see here I'm going to connect this also. Simply take one polyline from this ref net, simply select this one and connect this split AC. Then again continue this, continue here, connect this one. Polyline, use polyline command, select this point, go straight, then select this, simply connect this. Okay, and for these units, what I am doing, I am copying this one, copy this side, or simply copy this area, this one, use one more branch like this and connect this, move this one, move this reference here. Okay, use polyline, connect. Okay, move this one to here. Okay, now simply what you will do, simply take the polyline command like this, connect it here. Continue this one for the next unit here. Copy this one, copy this reference, paste it here. Okay, and this is the connection for this indoor unit, and this is the continuation. Okay, connected here. You can see here, this is the piping layout already done. So the next is for your second floor. So second floor, what you will do, simply copy this, the same piping layout, we are going to place the outdoor unit in the terrace for each floor. So what I am doing, I am going to move this one, I am going to place it here in this AC room. Okay, here. So for this one also need to do the piping layout. What I will do, I will take the PL with the PL polyline command and copy the reflect from here. Okay, we need to copy, paste it here. Okay, use PL polyline command on this point down, connect this one, again copy this reference, copy this side, again use PL polyline command. This point to this point, paste it here. Simply connect this, then again use polyline, continue this line, again use this another reference, copy and paste it here. Move this one bit here. Okay, again use polyline command. Okay, paste it here. Continue this. Use one tablet here. I'm going to copy this. I'm going to paste it here. For this one, I'm going to use one more reference this side. Rotate this. Paste it here. Okay. Simply copy this, connect this unit. What I'm going to do here, copy this reference and paste it here. Okay. Now continue this one for this AC. Okay. You can see here this already connected all these units, and these are balanced. So connect this also. I'm going to use one more reference here. Okay. Okay, so these are connected, and next is this one. Okay, so you can see here this is the second floor. Also, I already connect the piping layout from indoor to outdoor. Now the next is second floor. So for second floor, what I am doing, I am going to copy this all. I'm going to copy this one, all the piping layouts. So outdoor unit, I'm going to copy, paste it here, third floor, and the same I'm going to paste on fourth floor. Okay, and the fifth floor, what I'm going to do, I'm going to simply connect this outdoor unit to the indoor unit, because this is split AC only, cassette type split AC. Okay, you can see here I have done the piping layout for each floor. This is the ground floor is no matter, this is the split AC, and the first floor is the VRF, second floor is also VRF. One unit is going to serve entire floor, and this is third floor, the VRF also, and fourth floor is VRF as well, and next is fifth floor. So fifth floor is only one room, so I'm going to use the cassette split. So this is a split type only. So what we did already the our next step, this piping layout between indoor and outdoor. Now the equipment is already selected, so we are going to do the designing for the fresh air unit. Okay, and then next step is we are going to do the pipe sizing manually using the chart. I will show you the chart. This is the manual pipe sizing chart. Okay, according to this chart we are going to do the pipe sizing. After the pipe sizing, we are going to do the fresh air ducting layout FAHU. We are going to select and design the FAHU as well as ducting for the fresh air unit, and after that finally we have to place